Alrighty, welcome back. Today we're going to start 12.4, which is linear functions. Linear functions. So, we've got a few pieces of information. So something like x equals a constant, say 4, we know that's a vertical plane in x. Y equals some number, that's going to be a vertical plane in y. Z equals some number, some constant, we get a horizontal plane. Okay, so those are, the planes that we have so far. We do have a couple other equations, and that's what we want to talk about. What about the other planes? Tilted planes, or sloped. That's what we want to talk about today. So we're going to have a slope in the x direction and a slope in the y direction. Alrighty, so if a plane has, let's call it M slope in x direction and N slope in y direction and passes through the point, that's a T, and this is an H, through the point x naught, y naught, z naught, then where should I be? Right here. Then the plane has, oh good grief, has, sorry, equation. Okay, so you could do z minus z naught equals m x minus x naught plus n y minus y naught. Right, and that's in 3D. Right, where am I? Right over here. So remember 2D. You could write the equation of the line y minus y naught equals mx minus x naught. Okay, and that went through the point x naught, y naught. Okay, so often we don't just leave it like this. We move the z over, so we have z equals z naught plus m x minus x naught plus n y minus y naught. And this is going to be, well, and actually we're not going to do, we do more than that too, right? So remember we would, let's see, let's distribute. So I'm going to have mx plus ny plus, okay, there's the z naught minus mx naught minus ny naught, and this piece is a constant, right? Because they're all constants. So we would get z equals mx plus ny plus a constant, where c equals z naught minus mx naught minus ny naught. Okay, constant. And then this, so, you can use this. You can use this. You can use this, right? We have a linear function in 3D. Okay, so there. So there, great. Okay, so let's do an example. Here's my example, here we go. Let's find equation passing through the points 1, 0, 1, 1, minus 1, 3, and 3, 0, negative 1. Okay. So all we have is 3 points here, so there's a few things that we can do. So remember, we want to get to z equals mx plus ny plus c. All right, so I can plug in point A. We'll call this B, call this C. So I can plug in point A, right? And I would get z is 1 equals m, x is 1. I don't really need to, okay, 1, fine. And y is 0. And that gives me the equation 1 minus c equals m. Right? M, there's c, and there's not this piece. Okay. I can plug in, say, point C. Alrighty, so we get y is 3. X, oops, y is not 3. Y, or z, sorry, z. Gotta erase that. There we go. Okay, we're plugging in point C. I don't know how to read apparently. So y is negative 1. And there's the m. X is 3. Plus there's the n. Y is 0, and there's plus c. And this says, okay, what does this say? This says minus 1, move the c over, minus c, divide by 3 equals m. And now I have a way to equate m, because m equals m, right? They're equal. So we could have 1 minus c equals minus 1 minus c over 3. Multiply through the 3, you get 3 minus 3c equals minus 1 minus c. Let's add the 3c over, and then let's add the 1 over here, right? This is just algebra. And you get 4 equals 2c. Alrighty, so that tells me that 2 equals c. Got one thing done. Okay. Now, oh, what's going on? All right, fine. All right, and now what do we have up here? So I'm going to rewrite this again. Minus 1 equals 3m plus c. So I'm going to now put that c in. So I'll get minus 1 equals 3m plus 2. Subtract the 2. Subtract the 2. I get minus 3 equals 3m, and that tells me that minus 1 equals m. So I have solved for m. And I haven't used b yet, so let's go ahead and plug in for b. What is b? b says z is 3 equals, there's the m, x is 1 plus n, y is negative 1, and plus c. Okay, so I get 3 equals m minus n plus c, but I'm going to put the m in, and I'm going to put the c in. Oh, excuse me. And I get 3 equals, minus m, which is, m, which is minus 1. There's the minus n, and here's plus 2 for the c. So I get 3 equals minus n plus 1, and I'm going to subtract the 1, and I'm going to get 2 equals minus n, and this tells me that n equals 2. So I have my all those pieces, right? So what that says is z equals m x plus n y plus c. There we go. Which actually we'd probably write as z equals minus x plus 2y plus c. There's an equation of the line in 3D. Of course, usually probably have c listed for, oh, that's a 2, sorry. Where am I? That should be a 2, right? This should be a 2 because I plugged in. There we go. Okay. Remember, my equation of the line is mx plus ny plus c. Okay. And there we have it. We solved them all. Okay, that's one way of doing it. One way of doing it. So let's look at another way. I didn't use my fancy down button. Okay, so remember we were looking for a line through the points 1, 0, 1, 1, negative 1, 3, and 3, 0, negative 1. And notice this x is a 1 and this x is a 1. So for x equals 1, n is going to be the change in z over the change in y. So the change in z is 3 minus 1 over the change in y is minus 1 minus 0. And we get 2 over negative 1, which is negative 2. So n equals negative 2, which, oops, typo up here. Where's my pen? Go back. Oh, here. Look, that says minus 1. Here's my typo. N is negative 2. Oops. Alrighty. Zoop. Zoop. There we go. Yep. Minus 2 equals minus n. N equals minus 2. Oh. I erased the wrong one. N is minus 2. There's my minus 2. That was my coughing fit. And C was 2. Let's go. Put in back my pluses I erroneously erased. There we go. Okay. Okay, so we got that one. Now let's look. In fact, I'm going to change color here because I can't. I don't need it that fat, maybe. Okay, so now look, I've got another couple things that are equal. Here's y is 0, and here y is 0. So for y equals 0, m is going to equal the change in z over the change in y. X. X, right? So change in z, for the blue, is negative 1 minus 1.